Hello, this is Team Jusdoit, and this is our submission for the Hackathon HackQuinox. Yeah, so our problem statement is of AI/ML domain, the third one, which deals with the finding the root cause or patterns to understand and diagnose potentially um, different learning disabilities. We chose to go with dyslexia. So yeah, this is our submission. Let's go ahead with the flowchart, Anurag. You mean?
Yeah, sure. So this is the flowchart. So I will give you the basic details what is in the flowchart. So first the user will put their details like creating their profile, and then after that in the app there will be a test, and that test is not normal test. There it is a dynamic test. Like there, as you can see, there is 9 topics. So depending on these topics, the test will be conducted, uh, and how the user is performing on the ongoing test. It our AI model will detect that and make the difficulty of the test because it is a dynamic test. And then after that, there is a gamified interface of in our app. So any child can use that without any complexity. And after that, the data is collected, and from that data, we used AI and ML to detect analysis and pattern detection of the performance of the child. And from that, we categorize the data that this child is having dyslexia or this child is normal. So, if the child is detected dyslexia, then we provide the detailed report recommendation and helps for improvement and give suggestion like personal help, parental guidance. And if the child is not having dyslexia, then we there is an option for retake or optional test. So in that, the child can give test again and again to uh, check that if he is having dyslexia or not. Then after that, then there is digital twin data, which is used to save the यूजर्स डेटा फॉर एग्जांपल लाइक अगर मैं एग्ज़ाम दे रहा हूँ तो मेरा जो भी परफॉर्मेंस का डेटा रहेगा, जो भी मैंने जैसे आंसर किया है, जो मेरा रिजल्ट आया है, वो सब एक डिजिटल ट्विन में सेव रहेगा। तो जब भी मेरे को वो चाहिए रहेगा तो वो वहाँ से डायरेक्ट मेरे को मिल सकता है, रिडायरेक्ट हो जाएगा। सो आफ्टर सो दैट इज़ लाइक वी कैन व्यू आवर प्रोग्रेस एंड डाउनलोड एंड शेयर आवर रिपोर्ट एंड दैट्स इट।
Yeah. So while we were exploring the problem statement, we came across problem that is not having enough relevant and accurate data for actually basing our ML model from. So we decided to break down this problem statement into two separate parts. One dealing with the data conditions right now, and the other one being the ML model. So the first part is a test which is completely based on different research papers that we could find and the current IRL used cognitive diagnosis that people in this profession, you know, go through to actually diagnose a patient. And we extracted 9 such tests for our suitability of the ML model, and then we took it to the ML model, which I'll come to in a bit, talking about this part of the solution. This part is totally gamified, so a child or even a teenager will not face any issues of uh, unfamiliar difficulty, and the UI is very user friendly. That being said, our solution tries to tackle the problem using reinforced learning. And the reason behind that is again the lack of data. If we use any data set which is not relevant and not accurate, then we are not actually building a smart machine. Yeah, so our reinforced model keeps on getting better the more data we give uh, to it, and the more you know that he can process. Yeah, so talking about the ML model, हम लोग YouTube वीडियो में तो उसका चर्चा नहीं कर सकते. Anyways, we have developed the architecture for it. We have not completed the code because that was not needed at this particular stage. Uh, the model of uh, this particular thing being a multimodal solution, which is which encompasses of RNNs, GNNs, GVMs, and transformer models. What we do, if I go through it in a very swift manner, we take the results from these tests, which are accuracy, precision, let's say, or response time, coordination function. uh, All these are put into a vector space using one class SVMs, and after putting it, cluster them and try to improvise the pattern as we go through the test. That's why it is a dynamic model. As we go through the test, we find certain patterns. Basically, uh, if if I specify the GNN models, they correlate or interconnect different test results, which are in some manner correlated, like the delaying naming correlation and the sound deletion test. These two tests being in a cognitive function, which are which are very interrelated after all. Our GNN model also places them closer together, so we can find any variance to be a match, and we can go in that direction. That yeah, we may assume this kid or this child may have a certain learning disabilities. Yeah, it also uses RNN models, bidirectional LSTMs, which redirects the dependencies based on the test performance, which is repeated mistakes or a particular sense of disability. That is, it may be uh, relating to time, it may be relating to cognitive function. Yeah, so that is our entire model. We also have transformer models to contextually fit these relationships with each other, and at the end of the day, we have an encoder ensemble which gathers all this data of different models and classifies the report, either being likely to go towards learning disorders or not. If we do, we generate a detailed report on which functions or cognitive functions are weak, and we advise to consult a professional. Yeah, thank you.